Hi guys, Sam Marsden here from the Wolfhound channel. This is the first episode of my series in Python for engineers and for beginners. Now in this series I'm going to cover everything you need to become a professional programmer and developer. I'm assuming you've got Python installed. If you're having any issues, I will have a separate video basically on how to get it installed and up and running, but assuming you've got it there, we're going to be beginning from that point. Now, what I'm going to do as part of this is I'm going to be covering a book that I used 10 years ago to get me into the field of programming. I'm going to transition here just so I get the authors in the book right. So you should be able to see on screen the book's How to Think Like a Computer Scientist. The link is there. It'll also be in the description below. And I recommend you read through the book first, the chapters, chapter by chapter. I'll be following them. And essentially I'll be teaching you sort of the things that I struggled with because I wasn't a programmer, I didn't come from a computer science background, and I will explain the difficulties but also the practical side of it. What do I use as a developer? What is relative to you in learning? So that's the book, and I recommend, as I said, you read along with me and we go through it together, and I'll also be giving you examples and different things to try out along the way. Now, the first thing we're going to talk about is our development environment. And this is really a tool that programmers use to help them write programs better, to debug, to check if they've made any mistakes, and just to run the program in general. There are a lot out there that come with different features. The one that's bundled with Python is called idle, and it's very cut down. And I recommend that you use that because it really is going to teach you how to be the best programmer you can, because it has the cut down skill set. It's a bit like learning a new sport. You don't want to go out and buy the best, most expensive equipment because you're not going to know how to use it. As you grow as a developer, the tools you use will grow. So I'm going to be using idle, which I'm going to pop up here on screen for you. So you can see here the immediate mode, which is the shell, the Python shell. And there are two modes. There's the immediate mode and the scripting mode. The immediate mode, I'm going to be honest with you guys, we don't really use. As a professional developer, I use this occasionally to check some things, to type the odd command in just to get stuff up and running. It's not really used that much. We more use the scripting mode, but I'll show you this anyway. So this is the immediate mode. If I put in 10, hit enter, it returns a value of 10. If I hit x equals 10, we will assign a value to x, which is 10. If we then hit x and enter, you can see it's giving us the value of 10. Now, if we want to save our programs and be able to debug them better, we're going to create a script. So you're going to go up here, you're going to go File, New, and what you're going to get is I have one here earlier, this here. This is a script. And what we're doing is basically the same thing. We're just assigning a value to x and then we're printing x. The main difference here is for us to get something to show up, we have to explicitly say that we want to print it, that we want to print it to the shell, that we want it to come up in the interpreter that we're using. So I'm going to run this. It will normally ask you to save. Actually, I changed the value to 12. That way it will ask me to save. You can press F5 to run it, or just click there, hit OK to save, it'll run, and now it'll print the value of 12 to the screen. So you can see that there, that's the Python interpreter, and we'll be working with that. The interpreter that I use is this. This is PyCharm. Now, this has loads of bells and whistles. I barely use half of them, to be honest with you. And like I said, I stuck with idle for a couple of years just to make me a better programmer, but this is a tool out there. A lot of professional engineers use it. I'll just run this script here. This is a program that I built myself, which is dyslexic text-to-speech software. It's written in Python. I'm just going to take a screenshot of my screen. It's going to pop this up in this box there. Fantastic. It's done OCR. It's done all the text-to-speech. I'm now going to play it for you, and hopefully you guys will hear it. So hit play.
This is a lot of 12-point text to test the OCR code and see if it works on all types of file format.
Okay, so hopefully you'll be able to hear that on your screen. Moving on, we're going to talk now about section 1.2, what is a program? So there is a certain amount of common instructions through all programs. In the book, it talks about your inputs, which can be keyboard typing interrupts, along with files and data from other devices. Now, to build on that, I would say you can get GPS data, you can get text messages, or you can just get buttons being pressed, like remote I/O, for instance. It also talks about outputs. This can be displaying to screens or writing data to files. The thing I would say there, in my experience, you can also turn motors on and off, turn other things on and off like lights, and you can also make requests to websites, which I can show you in a separate video. We also have conditionals, and the best way for me to explain this to you is really like the classic burglar alarm. This is, whenever you've got, pressure sensors or motion sensors, and you have conditions that are met. Something is triggered, or for instance, you have temperatures. You have, it's above a certain temperature today, it's below a certain temperature. If it gets too hot, we can turn on the sprinkler system because we think there's a fire. We also have things like light sensors, and that's what conditionals are more sort of like and about. We also have mathematics. So anything you can do with pen and paper, you can do in a programming language. You can do in Python, and it will execute thousands, if not millions of times faster than you can possibly do it. And building on that, we also have repetition. The program can do it over and over and over again the exact same way. It's like Excel spreadsheet on steroids. And this is where the real power of programming comes in. Whenever you need to do something over and over again, be accurate, and get the results out, and in a condensed form, and you don't care about all the working out. You don't want to deal with all the paperwork. So going on from that, we're going to talk about the next section, which is 1.3, what is debugging? This is something I really didn't understand whenever I started programming. I didn't understand what bugs were, but really all they are is a bug in your program, which I can show you here. So we've got our immediate mode and all the rest of it, and we're going to talk about a semantic error. So this essentially is a spelling mistake. This is whenever you try and write, say, x equals 10 to me in the variable, which is Sam, and then we try and call it, but we forget the capital letter. And we're going to get a semantic error. The variable with the lowercase is not defined. And that's how precise you have to be. If we go back to our analogy of essentially, a blind man walking into your house, he doesn't know where anything is. If you tell him to go to the fridge, open the door, and take the milk in the door, he'll take the first one, and he won't know maybe it's almond milk, and he'll bake your cake with almond milk, and it'll taste gross because almond milk is gross. The same thing happens if you get the whole way through, you've got the cake all mixed already, you put it in the oven, turn the oven on, but you forget to close the door, and all the heat gets let out. That's really how precise you need to be with programming and how you need to think about it. In saying that, I'm massively dyslexic. It's never been an issue for me. Honestly, I wrote a cheat sheet down. Any times I made any errors like that, I would just add to my cheat sheet, keep it in my pocket, and worst case scenario, if there's a big long word I needed to spell, cut and paste from elsewhere in the program, job done. We also have runtime errors. Now, what a runtime error is where the program doesn't understand what to do, or it can't handle the command that's being given. This can be, for instance, trying to add something like a name, like Sam, like text, to a number, 5. And the program goes, well, I don't really know how to do that. You can't really add a name to 5 and get out a number value. You can get out a string, but that's different. And also things like dividing through by 0, because it's just going to go to infinity, and the program's going to go, I have no idea what to do here. And essentially, it is just like that person in your house going around, they don't know what to do if they come to something that they don't know how to handle. Moving on, we have semantic errors. Now, semantic errors are really, you've written your program, there isn't any spelling mistakes, there isn't any silly errors where you're trying to divide by 0, but you're not getting the result you want. So this can be if you write, for instance, a program that's trying to add 2 and 2 together, but instead of getting 4, you get 3. And it can feel frustrating at times. I know I felt it where I felt like there's definitely something wrong with the program. 99.99% of the time, it's not going to be, unless you're into some weird debugging areas and you're working on the peripherals with some odd modules. I guarantee you, it's you. And in saying that, the best way to write your code is really modular, and that brings us on to our next point, which is 1.7, experimental debugging. And this is whenever you write a section of code, small section or a function, and then you write another bit of code to test that function. I know that sounds like a waste of time, but trust me, as a professional programmer, this is how it's done. This is how you go to your boss and you say, my program works, and your boss goes, how do you know? And you go, because I've got a script that checks it, that gives me the right outputs, that confirms it's going to work. And that is critical. Trust me, in a professional setting, being able to guarantee that your program works is gold. That is what I have to do to verify my code before it goes out the door. That is the whole process. Because if you put in something that malfunctions, it costs businesses thousands and millions. So that's the real big takeaway, is you write the unit code and you write the test for that specific function, you add those functions together, you then test those functions in a block together, and then you take that block and add it to a bigger block and you test that. And once you're certain it's all working correctly, then you roll it out the door. And that's how you get rid of all your bugs. Right, so moving on to section 1.8, formal and natural languages. And in this section in the book, it really is just going over how precise we need to be with the instructions we give to the computer. And as I said before, I'm massively dyslexic. I make the odd spelling mistake in my programs. I make the odd different type of error. If you've done your testing right, if you've done your debugging right, it's not a big deal. It genuinely does not affect me in my day-to-day programming as a professional engineer or professional program developer. You might make a few spelling mistakes for the first few months or weeks. Stick with it. It's not an issue, and have a cheat sheet like I did. Going on, we're going to talk about our first program now. So we're going to basically print, and we're going to put in parentheses, hello world, which is the standard for computer programmers for the first program you'll ever write. And I know it's boring, but bear in mind, we're starting with the building blocks here. And do remember that as part of your script, if you want it to show up, you have to put it in print. You have to put it in a print statement, regardless of what it is. So going on from there, we're also going to talk about comments. So if you want to put a comment in afterwards and you want to write anything to make sure the program doesn't try and interpret it, doesn't try and execute it as code, we just put a hash. We can then say this code does X, Y, and Z. And that's very useful, although use comments sparingly. A rule in industry is as soon as you write a comment, it's technically out of date because someone can come after you and change the program to do something completely different. So you want to write your program as explicitly as possible, so it is clear without any comments what it is you're trying to achieve. But where you need to, you can put them in like that. For larger blocks of text, you can put in triple quotes and you can just write whatever you want. Like I said, I'm dyslexic, so I'm not going to try and spell everything correctly. And that's great if you're talking about the overarching picture of what it is a large program is trying to do. But yet again, try and keep it to a minimum, try and keep it to concise points, and just don't waffle. General rule for life. And moving on, we'll talk about some examples now, so I'll just get rid of that. So I'll run you through some of the basic mathematics, and we will expand on this, but if we just want to do some adding, you know, it'll show up there. We'll do some subtraction as well. We can do multiplication using the star, and we can do division, dead simple, and we'll do division like that actually. And you can see here we get a decimal, and also we can take things into the exponent with 2 stars, as you see there. Now the important thing is, do remember, if you're doing that in a script, you need to put them in a print statement, or you need to save them to a variable. So if we go x equals 5 times 6, it's not going to show up. It's not going to show up in a script like that. We can call it here from the interpreters like x like that, or we put it in a print statement. But yet again, we'll move on to that. I know this video was long, but hopefully that gives you the groundwork, and I'll try and cut the videos down, make them a bit tighter for you. But if you've enjoyed this, like and subscribe, hit the bell to stay notified, and until then, I'll see you next time.